All right, this is an application of logarithms question. Question 3. Jess invests $12,000 at a rate of 4.75% compounded monthly. How long will it take for Jess to triple her investment? Express your answer in years, correct to 3 decimal places. So the reason this is a logarithmic question is because we're looking for a variable exponent. So the formula that we want to start with is the amount in the bank equals your principal outside of 1 plus r divided by n, all to the nt. So we're going to read this over and pick out what we have. So her initial investment is the principal, so that's your $12,000. Your interest rate obviously is 4.75, but that has to be expressed as a decimal. So you would go 4.75 divided by 100 and get 4.0475. So the rate always has to be a decimal. Compounded monthly means that interest is compounded 12 times per year. So n is 12. And what we're looking for is time. In order for Jess to triple her investment, we actually also know the amount we want to end up with, and that is we want to end up with 36,000. So if we substitute in what we have, 36,000 equals 12,000 outside of 1 plus your interest rate, so that's decimal 0.0475 divided by 12, all to the 12t. So the very first thing you should do, besides doing the exponent, is I like to change the problem. Instead of starting with 12,000 and going to 36,000, I like to start with $1 and go to $3. So I'm going to cancel out the 12,000s, and that gives me a 1. And then the 12,000 over here will go ahead and give me 3. So it's just a known fact that the time it takes to go from $12,000 to $36,000 is equivalent to the time it would take to go from $1 to $3. Now to do the other part, I'm going to use my calculator. So I want to make sure I go brackets, and I'll do the division first. So I'm going to clear this out from the last problem there. 0.0475 divided by 12 equals that. And then I got to add 1. In my opinion, this is a terribly designed question because we're getting ugly decimals, but I guess in life there's ugly decimals. So we need to go in and say 1.0039. Don't just keep 3 decimals. 583. And it looks like 3 is repeating because we're dividing by 12. All to the 12t. So I will use the answer on my calculator from here on. But before I could do that, I need to solve for time. And this is where we use logs. I have a variable exponent, so I need to log both sides. So I'm taking the natural log of 3, and then that equals the natural log of this whole side, 1.003958 repeating, all to the 12t. So the wonderful property of logs allows us to take down our exponent and put it to the front of the expression. So if we continue on here, natural log of 3 equals 12t. Natural log of 1.003958 repeating. So you can see our exponent moved down in front of the expression. So lastly, we want to isolate t, in other words, get it by itself. So we can divide both sides of our equation by the same expression. So I'm going to divide this by 12 because that will cancel and give me 1. And I also need to divide by natural log of 1.0039583. And if I do that to the left, I also need to do it to the right. Going to be a little bit jam-packed here, but hopefully your marker wouldn't mind. 9583. A little bit ugly looking here. Just want to show that that's being canceled out. So now whenever you do division with logs and using your calculator, you want to show top divided by bottom. So I always put brackets around top, although in this case they're not really necessary, but a bracket around to close the 3 and then a bracket to close the top, divided by, you need to open the brackets for the bottom because it's all on the bottom. 12 times natural log. Oops, haven't used this calculator in a while. That's not what I want. Let me delete that. Natural log 1 point. Oh, sorry. I'm not gonna use that. I'm just gonna put in the answer that's on my calculator. So it saves me the trouble of typing it all in. And close the bracket. Close it again. So first bracket was closed for the natural log. Second bracket's closed for the bottom. And then I get my answer. And remember, this answer would be years. So 23.174 years. And now this is the only time we round. All right, so that seems reasonable amount of time to triple your interest rate.